Hello everyone, welcome to our channel Clear and Concise. In this video, I am explaining you ISRO Mechanical Engineering previous year questions with solutions. Let's have a look at this question. If the Poisson's ratio for the material is 0.5, then the elastic modulus for the material is. For linear elastic and isotropic materials, elastic modulus E is equals to 2g times 1 plus nu, where nu is Poisson's ratio of the material, g is shear modulus, E is elastic modulus. In the problem, Poisson's ratio nu is given as 0.5. So by substituting nu equals to 0.5 in the equation, we will get 2g times 1 plus 0.5, that is equals to 1.5 times 2, that is 3g. E is equals to 3g, that is elastic modulus of the material is 3 times the shear modulus. The correct answer is option A, 3 times its shear modulus. Moving on to the next question. A cantilever beam of negligible weight is carrying a mass m at its free end and is also resting on an elastic support of stiffness K1 as shown in the figure. If K2 represents the bending stiffness of the beam, the natural frequency of the system is. We have to find natural frequency of the system, which is equals to square root of K equivalent, that is equivalent stiffness of the system, over mass m. Now we need to find equivalent stiffness for the given system, that is K equivalence. So if we draw equivalent spring mass system for the given system, we will have a beam which is having stiffness K2, where mass m is attached at its free end and is resting on an elastic support of stiffness K1. So this system is clearly a parallel arrangement of spring mass system because mass m is supported by both the springs having stiffness K1, K2, and the deflection in both the springs is equals to delta, that is delta 1 is equals to delta 2, because the elongation in the spring having stiffness K2 is equals to the compression in the spring having stiffness K1. So delta 1 is equals to delta 2. Now for parallel arrangement, equivalent stiffness is equals to summation of all the stiffnesses in the system. Therefore K1 plus K2 is equals to equivalent stiffness of the system. Now omega is equals to square root of, substituting K equivalent in the equation yields K1 plus K2 over mass of the system m. So the correct answer is option C, K1 plus K2 by m. Let's solve this question. The figure shows 3 small spheres that rotate about a vertical axis. The perpendicular distance between the axis and center of each sphere is given. Mass of highest rotational inertia about that axis is. Rotational inertia of mass m is given as I equals to mr square, where m is mass, r is the perpendicular distance from the axis. Now for the mass of 36 kg, r is equals to 1 meter from the problem. So moment of inertia I is equals to mr square, that is 36 times 1 square, which is equals to 36 kg meter square. For the mass of 9 kg, r given in the problem is 2 meters. So I is equals to mr square, that is 9 kg times r square, that is 2 square, which is equals to 36 kg meter square again. For the other mass, that is 4 kg, r is given as 3 meters. Moment of inertia I is equals to 4 r square, that is 4 times 3 square, which is equals to 36 kg meter square. So for all the systems, the moment of inertia is same, that is 36 kg. So the correct answer is option D, all same. Moving on to the next question. Which of the following relationships between the force F on a particle and the particle's position x implies the simple harmonic oscillation? The definition of simple harmonic oscillation is force is directly proportional to the displacement and it acts always in the opposite direction to the motion of the particle. So, if we observe the options, option A seems to be correct because here force is equals to minus 7x and this negative sign signifies that the force and displacements are in opposite directions. This F is restoring force of the system which always acts in the opposite direction to the motion of the particle. For example, if we have a spring, if we pull the mass in positive x direction, the restoring force F always acts in the opposite direction. So for this kind of system, F is directly proportional to the x and acts always in the opposite direction. So the option A is correct answer. Let's have a look at this question. A mass of 100 kg is held between two springs as shown in the figure. The natural frequency of the system in cycles per second is. The angular frequency omega is defined as square root of K equivalent over mass m. Here equivalent stiffness of the system K is equals to K1 plus K2 because the given system is parallel arrangement of spring mass system. So 20 plus 20, that is equals to 40 kilonewton per meter and the mass in the system is 100 kg. So omega is equals to square root of K equivalent, that is 40 kilo is 10 cube over mass m, that is 100 kg. 40,000 by 100 is equals to 400. So square root of 400 is equals to 20 radians per second. So we have obtained angular frequency and we know omega is equals to 2 pi f. We need to find f, that is equals to omega by 2 pi. That is equals to 20 by 2 pi. We have 10 by pi cycles per second. So the correct answer is option A, 10 by pi. Let's solve this question. The bending equation is written as m by I is equals to F by Y, that is equals to E by R. The correct answer is option C, where m is bending moment of the beam, I is second moment of area of the beam cross section, F is bending stress, Y is the distance of layer where we are calculating stress from the neutral axis, E is elastic modulus of the beam and R is radius of curvature. The correct answer is option C. Let's solve this question. Hydraulic test of boilers is done at pressures. Option D is the correct answer, at 1.5 to 2 times the working pressure. Generally, hydraulic test is carried out at pressures more than 110%, that is 1.1 times to 1.25 times. So the correct answer is option D, 1.5 to 2 times the working pressure. Let's have a look at this question. 100 meter of water column is equals to. We need to convert water column into pressure. So pressure P is equals to rho GH, where rho is density of liquid, G is gravitational constant, H is column. Here the liquid is water, so density is 1000 and G is approximately 10 meters per second square, which is actually 9.81, but let's round it off to 10, and the water column H is equals to 100 meters. So the correct answer is 1000 kilo Newton per meter square. So the option A is the correct answer. Let's have a look at this question. Gantry girders are invariably designed to resist. These are generally designed to resist all the loads like transverse, lateral and axial loads. So the correct answer is option D, transverse, lateral and axial loads. Let's solve this question. If the rotating mass of a rim type flywheel is distributed on another rim type flywheel whose mean radius is half of the radius of the former, then the energy stored in the latter at the same speed will be. We have to find kinetic energy, which is defined as half I omega square, where I is moment of inertia of flywheel, omega is speed of the flywheel, angular speed. Now I is equals to mr square, where m is mass of the flywheel, r is radius of the flywheel. So substituting that, Ke is equals to half m r square omega square. Now after reducing the radius to half, kinetic energy is equals to half of m r is capital R by 2 square omega square, that is equals to 1 by 2 times m r square omega square by 4. So the correct answer is 1 and 4 times the first one, 1/4 of the first one. Option C is the correct option.